Hi everyone, I'm back with another Leetcode problem, and this is a problem within the blind 75 list. So today's problem is problem 23, merge k sorted lists. So the name suggests what we have to do. We are given k linked list, and each of these lists are sorted in ascending order. So we have to merge all of that linked list into one sorted linked list and return it. Okay, so how do we do this? So one idea is say we have like k sorted list, right? So this is one list, this is the other list, right? And this is the other list. So obviously we know that we have to compare. First, we have to compare between the first elements, right? And whatever is the smallest element, then we take that is the first one. So say this is the smallest element. So there goes the first one. And then next, we have to compare between this and this and this, right? To find the smallest one. And for that, say this is the next smallest one. So we bring it here, right? And next time I have to compare between this, and this, right? Okay. So every time actually we are practically comparing the front of the list, all the front of the lists, and then taking the minimum, uh, and whatever is the minimum, I move the front of that list to the next element, right? Okay, so what is let's think about a good data structure that can actually help us doing this, because we can actually do it manually every time, but every time I have to do like k comparisons and other stuff. So can we optimize a bit on that? So what about keeping say a priority queue or heap? Say you see here the first example, right? So for the first example, you see it's 1, 4, 5. So it's 1, 4, and 5, right? So this is the first list. And then the next list is a 1, 3, and 4. That is the next one. And then the next list is 2 and 6, right? Okay. So these are the three lists. So why can we keep a priority queue? Say priority queue of say let's keep this as um, min heap. So if we have a min heap, that way um, the smallest value always remains on the top, and that will actually help us. So we can actually push the nodes. So let's push the nodes. So this node is going to be pushed. Initially, you are going to push all k nodes, right? So k nodes, we're going to add these k nodes into the priority queue. So it's going to be 1, and then 2, and then also at the top is 1 is going to stay on the top, right? So these things are in the queue, in the priority queue. And the size of the queue is always say k, right? Because we took one node from each of the lists. And okay, now what do we next? So we have actually done like added the front of each list to the priority queue. Now we take this out, right? So we take this out, and so basically it will take this out. So suppose this one is actually getting taken out, right? So before I take this out, uh, so let's keep this thing like say we have a dummy node. So we have a dummy node, which is a current node. So the current node is say set to something. So this is the current. So we take this out. By taking this out, basically I'm taking this thing out. So I make this one as a current next to the current, right? So I not only take this out, next what I do is I add, so I add the next one. Okay, so I take this out. That means this one is taken out. I make it next to the current. And then I set this as the new current. Okay. and I check if the next to the current is not null. If that is not null, I just add it. I add it to the heap. So if I add to the heap, actually 1 is going up and 4 is going here, right? Okay. Okay, so that's it. Next, I take this out. So this is basically I'm taking this thing out, right? So I make it the next of current. So that means this one is now becoming next of current. Okay, so I have taken this out. And this, I make this one as the new current. I check if the next of the current is not null. It's not null. So this one 3 is going to be added, right? So if I add 3, you see 2 will be at the top and 3 is going to be here, right? Okay. Next, I take 2 out. So basically 2 out, and so basically I'm taking this thing out, making it the next of the current. So this one becomes the next, and set is as current. Okay. And next, so 6 is going to be added next. You see 6 is going to be added. So 6 will be here and 3 will go up, right? Okay. Next, I will take 3 out and make it, so I will just keep on doing this. So this one is going to be new current. 4 is going to be added. So 3 is taken out. 4 is going to be added. So there'll be 1 4 here and then another 4 here, right? Okay. So next I take this out. So you see this is going to be like this. This is new current. 5 is going to be added. So this 4 will go here. 5 is going to be added. Next I take 4 out. So you see this, right? I take 4 out. Now, one important thing, you see the next is null. So nothing is going to be added. Okay, and this one becomes the new current. By the way, this one was deleted. Okay, next so 5 actually comes here. Okay, so 5 is out now. Next 5 is out. I make a link from 4 to 5. Okay, and then 5 is taken out, and you see that nothing is going to be added, and 6 comes to the top, right? Okay, next, so this is the new current. Next, I take 6 out and make 6 as the next of 5, and that's it, and nothing else is added. So until I keep on doing this until my priority queue is empty, right? Okay, and so how much time it takes? So you see there are like, if I say there are like in total there are like n elements, right? For n elements, every time what I did is I did an add operation and then I took something out. So the size of the heap is maximum k. So it's log k operation for each, say, adding or removing, right? Add or remove is log k, and I did this add and remove thing n times. So this is time complexity, right? In log k. And the space complexity is, you see, I didn't use no extra space, no extra space. I use the existing ones, and only extra space that I used is this one. So space was order of k, because the maximum size of this heap was k. And finally, this was the first dummy node that I had taken. So I just return, say dummy.next. That will give me the head. Okay, so dummy.next is this one. So I return this. This is the head of the newly reordered list. So you see here is the code. We had this priority queue, and the basis of the priority queue is, this is a priority queue of the list nodes. We actually put the list node itself on the queue so that all the next links and other things are actually still alive. But the priority queue is based on the value of the nodes, right? Okay. And then we had this dummy node, and we make this dummy node as a current node. And then we go through each of the list and put the front of the list into the priority queue. That's the beginning. Then we keep on doing this while loop until the queue is empty. Every time I take the top of the heap and make it the next of the current, and then I change current to the current's next. Obviously, the newly added node becomes the current. And I check if the current's next is not null. In that case, I add it to the queue. Okay, see, I have shown you all the examples, all the illustrations. And finally, I return the dummy.next. So thanks for watching. We'll come back with another problem next time.